The Pacific Plate is a giant force beneath the ocean, shifting and shaping the planet in silence. Deep below its surface, molten rock and ancient pressures build toward events we are only beginning to understand.
And now for a look at stories making headlines around the world, and we start with a spate of natural disasters. A volatile ring of fire, a line of seismic faults in the Pacific Ocean has sparked earthquakes and volcanic eruptions on opposite ends of the ocean.
From the unfathomable depths beneath the Pacific Ocean, subtler than stormlight and older than any nation, Earth's largest tectonic plate flexes and churns, inscribing untold eons in silence and shattering calm with cataclysm. The Pacific Plate, a colossal raft of shifting lithosphere, bears both continents and abyssal wilds. It is the hidden engine of the world's greatest earthquakes, trench-carving subductions, and, perhaps, the ultimate volcanic secret. Far below coral archipelagos and fleets of fishing vessels, restless forces gather, molten rock, ancient voids, and memories of fire waiting to emerge. Recently, scientists have turned their gaze and instruments to a series of discoveries that pierce the shadows beneath the Pacific. Newfound calderas of unnerving scale, collapses at unseen margins, and reservoirs of magma stretching wider and deeper than any yet measured. The Apolaki caldera, revealed by careful surveying in the Philippine Sea, redefines every measurement of volcanic grandeur, dwarfing famous giants with its 150-kilometer reach. Beneath these vast structures lurk origins of devastation, the buried heart of Earth's grandest eruption, a secret rewritten after 120 million years. Subduction, collapse, and eruption intertwine in a chronicle of violence that shapes the ocean, the air, and the ground under our very lives. As we voyage through 20 of the most recent and extraordinary discoveries, each a single revelation from the world's greatest volcanic and tectonic stage, we face a question that rings in the pulse of every new tremor and every rise of the seabed. What dormant power lies veiled beneath the world's largest plate? And does it stir now, preparing to awaken with a force that could reshape our planet once more? Chapter 1. The discovery of the Apolaki caldera, a hidden giant. For generations, the deepest floors of the Philippine Sea held their peace, an expanse of blue above, and beneath, the quiet ruins of upheaval unseen by any human eye. Through sonar surveys and seismic readings, researchers uncovered the presence of something unmatched in terrestrial annals, the Apolaki caldera. Measuring nearly 150 kilometers, 93 miles across, this immense undersea bowl is not merely another seamount. It is Earth's largest caldera, a shell-shaped depression sculpted by titanic volcanic activity. Unlike volcanic craters familiar on land, Apolaki does not announce itself with smoke or steam. Instead, it sprawls in darkness, rimmed by steep walls and scattered volcanic flows. Its scale eclipses Yellowstone and Toba, forcing a reconsideration of volcanic violence's true limits. What forces could create such a vast scar in the sea floor? And what energies once convulsed here to leave behind this silent, underwater titan? Even as its dimensions come into focus, Apolaki raises fresh questions. Is this merely a remnant of ancient cataclysm? Or does it still contain potential for future upheaval? For scientists, every new data point brings a mix of awe and caution. If the phenomena that birthed Apolaki were to repeat, would there be warning? Or would the next eruption ripple across the globe, altering not only the seascape, but life itself? Chapter 2. The Restless Pacific Plate, Shifting Foundations. Beneath the Pacific's surface, a force older than any mountain or river tiles the crust, restlessly shifting, growing, and colliding. The Pacific Plate, Earth's largest tectonic plate, drifts atop the mantle, moving centimeters per year, yet shaping continents, trenches, and volcanic arcs over geologic time. Modern technology, from satellites to deep-sea instruments, tracks its movements with precision, revealing new details of its interactions and the immense forces at play. With every slow increment, the Pacific Plate bends, breaks, and reforms, building new ocean floor at mid-ocean ridges while plunging beneath other plates at subduction zones. Recent discoveries highlight how the plate's movement stirs the deep mantle, nourishing volcanic chains and creating the raw ingredients for unprecedented eruptions. What hidden structures might lie at its shifting borders? And what might the incremental stresses portend? The Pacific Plate's boundaries are sites of restless change. Massive stresses accumulate across thousands of miles, sometimes violently released in earthquakes, like those that have shaken the Pacific Rim. The act of subduction, where one plate sinks below another, melts crust, feeds the mantle, and fertilizes volcanic arcs, ensuring the ocean beneath is a realm of continuous renewal and hazard. Chapter 3. The mystery of Earth's largest eruption. Puzzle revealed. Volcanic history remembers only a handful of eruptions so immense they altered the planet. Toba, the Siberian traps, the Deccan floods. Now, through deep-sea mapping and geological coring, researchers have traced the origin of what may have been the greatest eruption of all, a mystery unsolved for over 120 million years, directly to the legacy of the Pacific Plate's tumultuous interior. Scattered layers of ash spread over continents and ocean beds are now linked to a colossal eruption that shaped sedimentary patterns worldwide. The discovery of the Apolaki caldera helps clarify these clues, connecting vast ash beds and unusual chemical signatures to a source hidden in deep time. This primeval event shaped not only rock, but climate and life itself. Could such violence rise again from the ocean depths? Piecing together the evidence, geologists find influences far beyond geology. Immense ash fallout, changes in atmosphere and climate, and periods of ecological disruption. The prospect of future eruptions of comparable scale, though uncertain, drives researchers to seek new signals and better understanding. Chapter 4. Submarine collapse. The plate beneath the plate. Recent seismic readings and gravitational data have revealed evidence that deep beneath the Pacific, segments of tectonic plate are collapsing under the weight of others. This subduction process is not always gradual. Sometimes slabs fracture or founder catastrophically, reshaping the mantle and generating earthquakes that ripple through thick oceanic crust. These movements can fuel new volcanic activity above, recharge magma chambers, and create new patterns of seismic risk. While the burial of these slabs is mainly a relic of ancient cycles, it shapes present and future conditions by facilitating flows of heat, minerals, and water deep below. The collapse may also trigger tsunamis or shift ocean currents, with far-reaching effects on our planet's systems. At tectonic margins, the cold, ancient plate descends, melting and releasing water and other materials, altering chemistry and fueling further eruptions. Here, the planet's internal machinery is at its most exposed. Chapter 5. Magma Oceans. Molten veins beneath the surface. Most of Earth's interior beneath the crust is dominated by the mantle, a vast realm of hot, slowly flowing rock, mostly solid but with pools and currents of molten magma. As the Pacific Plate moves and trenches deepen, these reservoirs rise and expand beneath the surface. Recent geophysical surveys have indicated that the magma pockets beneath submarine calderas like Apolaki are not only large, they are dynamic and variable over time. The chemistry of these magma reservoirs records the planet's ancient processes, while their movement and pressure are governed by tectonic changes above. As gases and molten material accumulate, the potential for explosive eruption quietly grows. If the structure above fails suddenly, an eruption could release energy beyond historic comparison. The Pacific Plate, acting as a kind of valve, plays a critical role in whether these molten chambers remain trapped or break free. Careful monitoring and modeling of these features help researchers anticipate possible futures for volcanic giants, and remind us that the planet's innermost forces are never entirely at rest. Chapter 6. Volcanic Chains. The Pacific's Fiery Highways. Across the Pacific, Lines of volcanoes, the result of hotspots and moving plates, trace the plate's journey. Hawaii, the Marianas, Samoa, and others mark the path of mantle plumes searing up through the drifting Pacific plate. These volcanic chains, emerging at seemingly regular intervals, chart the vast history of motion and deep Earth interaction. Recent mapping has clarified how the migration of the plate over plumes sparks chains of volcanic activity, giving birth to islands and undersea mountains. Each volcano represents a page in this grand geological story. From the volcanic archipelagos of Oceania to Alaska's rugged Aleutian Islands, where giants like Apolaki fit within this pattern, remains a subject of scientific debate and holds clues to possible future eruptions. Some volcanic chains extend for thousands of kilometers. Their rocks record the planet's shifting interior and the gradual progress of the Pacific plate over time. Chapter 7. Underwater Volcanoes, Silence and Secrecy. Unlike their land-bound kin, submarine volcanoes operate in a filtered world of pressure and permanent night, their eruptions muffled by the weight of water. Yet, recent advances in remote sensing and submersible vehicles have revealed just how common and powerful they are. The Pacific conceals thousands of undersea volcanoes, quietly adding to the sea floor and sometimes breaking the surface to form islands. Eruptions here are rarely witnessed, but their traces can be seen in mounds of pillow lava, hydrothermal vent fields, and landscape-scale flows. The ongoing construction of these features continues to shape the ocean landscape. While undersea eruptions don't always threaten human life directly, they play a significant role in altering ocean chemistry, building habitats, and, on rare occasions, sending giant plumes and debris flows across great distances. Chapter 8. Calderas within calderas, nested cataclysms. Research into the Philippine seafloor suggests complex histories for colossal calderas, where not only a single eruption, but cycles of collapse and renewal have shaped the landscape. Apolaki itself may include smaller nested calderas inside its vast depression, indicating repeated past events. By analysing volcanic deposits and the morphology of caldera walls, geologists are reconstructing a history of multiple super-eruptions, each one layering new geologic evidence on top of the last. Such cycles can persist for millions of years and represent a kind of repeatable geologic hazard. The danger is that another phase of rapid magma accumulation and eruption could one day resume this ancient cycle. A reminder that even the largest volcanic structures may host renewed activity given time. Nested calderas act as geological archives, recording both violent eruption and gradual subsidence, and help scientists understand the sequence and magnitude of past Pacific super-eruptions. Chapter 9. Subduction zones, gateways to destruction. The Pacific plate's edges are demarcated by vast trenches, subduction zones, where oceanic crust bends and sinks beneath neighbouring plates. These intersections are responsible for some of Earth's most violent earthquakes and the birth of entire volcanic arcs. Modern seismic imaging has revealed deeper complexity. Trenches often segment into smaller zones, with changing geometry and interconnected ruptures. As slabs descend, they partially melt, fueling volcanoes but can erupt with devastating force. These regions are crucial for understanding the Pacific's volatile margins, and accordingly, global volcanic risk. The greatest threats, megaquakes, tsunamis, and volcanic eruptions, arise where the Pacific plate is consumed, its old crust recycled and replaced by new, with energy building and occasionally bursting free. Chapter 10. Fossil magma chambers, petrified fire. Deep drilling into the oceanic crust uncovers the remnants of past infernos, solidified magma chambers that once fueled supervolcanoes like Apolaki. Geochemical analysis of these fossilized reservoirs provides vital clues to the heat and chemistry that drove ancient eruptions. Each relic offers a timeline of past volcanic activity, marking periods of rapid magmatic invasion and sudden release. The patterns found in these chambers Crystals, mineral layers, and gas bubbles help scientists decipher eruption cycles and potential triggers for future activity. These petrified chambers remind us of the planet's greater volcanic legacy, stretching back to an era before humans walked the Earth. Chapter 11. Signs of Impending Eruption. Monitoring the Abyss. Though the ocean muffles sound and hides sights, networks of seismometers, satellites, and underwater sensors now track the subtle signals of change near calderas like Apolaki. Small tremors, heat plumes, chemical surges, and shifts in the seafloor's shape may herald brewing unrest. While many such signals prove innocuous or transient, ongoing monitoring is critical. Patterns of deformation or concentrated seismicity could indicate unrest within a large chamber. However, predicting an actual eruption, especially one on a supervolcanic scale, remains extraordinarily difficult. Constant vigilance is the best defense, as even with modern tools, the deep ocean remains a difficult and shifting realm for monitoring. Scientists continue to pass daily streams of data in the hope of spotting the rare but critical signs of major change. Chapter 12. Giant volcanic debris flows, castles of ash. The rims of massive submarine calderas are surrounded by the remains of old landslides and debris flows, evidence of catastrophic flank failures. These events can instantaneously send billions of tons of material sliding down the slopes, reshaping the seafloor and altering ecosystems for hundreds of kilometers. Underwater mapping has revealed these flows in stunning detail, attesting to the scale and power of past eruptions. When triggered by volcanic or tectonic activity, such collapses may even produce tsunamis capable of crossing ocean basins. For marine life and coastal environments, the effects can be both immediate and lingering. Understanding the frequency and impact of these debris flows is crucial for assessing long-term hazard and for reconstructing the histories of giant calderas like Apolaki.
Chapter 13. Deep Sea Ash Layers, the planet's archive. Cores extracted from the sea floor reveal layer upon layer of volcanic ash, each a marker of explosive eruptions that once sent material circling the globe. Scientists link these deposits to their origin points, such as Apolaki, by analyzing mineral content and isotopic signatures. These ash layers are more than relics. They are vital clocks for reconstructing the timing, scale, and global footprint of prehistoric eruptions. They also chronicle how volcanic activity periodically alters atmospheric and oceanic systems, sometimes precipitating climatic shifts or extinctions. The sedimentary archive of the Pacific is thus both a record of disaster and a guide to the rhythms of Earth's interior. Chapter 14. Hydrothermal vents, life's fiery twins. Around faults, caldera rims, and undersea volcanic chains, hydrothermal vents spew mineral-rich, superheated water. These environments support unique, sunlight-free ecosystems, making them some of the most remarkable biological refuges on Earth. Recent research shows these communities can rebound rapidly after volcanic disturbance, as life recolonizes the vents in the aftermath. At the same time, eruptions can obliterate existing habitats, forcing renewed cycles of extinction and adaptation. Each vent field is a testament not just to life's resilience, but to the enduring power and unpredictability of Earth's internal heat. Chapter 15. Unusual plant fossils, botanical time capsules. Within layers of ash and volcanic sediment on submerged margins, rare plant fossils indicate that episodes of Pacific volcanism left deep marks on terrestrial life. Pollen, leaves, and woody fragments, rapidly buried by volcanic mud, provide insights into past climate and recovery after disaster. These fossils record not only devastation, but resilience. Following ashfall, pioneer species take root, and over time, forests re-establish themselves. Detailed study of these time capsules helps link Earth's biological rhythms to episodes of supervolcanic activity, providing a long-term perspective on survival and renewal in times of planetary upheaval. Chapter 16. Ash and Climate. Eruptions that change the air. It is not only the land that suffers when a massive caldera like Apolaki erupts. Layers of ash and sulfate, found both in terrestrial strata and deep-sea cores, show the reach of giant eruptions, sometimes changing sunlight and rainfall patterns for years. Research into ancient events has begun to quantify the relationship between volcanic activity and global climate, from volcanic winters to altered monsoons. While the specifics are still being worked out, the evidence points to eruptions as potential climate drivers, capable of altering world temperature and weather for decades, with implications reaching down to agriculture and ecosystems. Understanding these episodes is vital. They serve as reminders of the delicate equilibrium between Earth's surface and its restless interior. Chapter 17. Submerged Archaeological Sites. Echoes of Catastrophe. Though fully submerged, the margins of the Pacific Plate may still conceal the shadowy remains of human history. Settlements or artifacts that vanished beneath the waves due to rising sea levels or sudden geological change. Environmental shifts triggered by eruption, ashfall, land sinking, or tsunamis have shaped human settlement for millennia. While evidence for specific submerged sites is limited, research continues along coastal and shallow marine zones, searching for links between volcanic events and changes in human habitation. These potential sites add another layer to the epic interplay of geology and civilization on the Pacific. Chapter 18. Volcanic Islands. Birth and Death on the Faultline. Throughout the Pacific, chains of volcanic islands, Japan, the Marianas, remote atolls, stand as evidence of the plate's creative and destructive duality. New islands rise from the deep, built by eruptions, while others subside or erode back beneath the waves. Monitoring with satellites and hydroacoustics has revealed that land formation and destruction can occur on surprising timescales. While most eruptions are local, the cumulative effect over time is profound, crafting coastlines and fundamentally altering the geography of the ocean's rim. Each emergence or disappearance reminds us that geological processes do not pause for human timescales, and that the world's maps are always subject to revision. Chapter 19. Mantle Dynamics. The Deep Earth Connection. The Pacific Plate's unceasing journey is powered by the convective motions of the mantle, a vast zone of partially molten rock beneath the crust. Seismic studies reveal hot upwellings or plumes that rise to the surface and stimulate volcanic hotspots, playing a major role in tectonic processes. Intriguing discoveries suggest that ancient fossil plumes may have shaped past periods of heightened volcanism, their residue still detectable via variations in magnetic fields and seismic velocities. The link between deep Earth and surface catastrophe is continually explored by modern science, each anomaly offering a possible clue to future as well as past volcanic activity. Understanding these deep processes is a journey into the planet's oldest mysteries, with each new finding hinting at events that may, in time, again change the face of the Pacific. Chapter 20. Monitoring the Unknown. Waiting for the next awakening. Every instrument, core, and sensor is focused on one immovable question: what happens next? The Pacific is ringed and crisscrossed by monitoring equipment, watching for any signs, however subtle, of coming change. Bulges in the crust, tremors, surges in heat or volcanic gas. Each signal is a whisper from Earth's restless heart. Recent discoveries, be they swelling magma reservoirs, unusual seismic swarms, or rapid slips along fault lines, are reminders that the world's largest tectonic plate is neither stable nor quiet. Above, life continues on islands and coastlines, rarely noticing the forces at work below. Yet, the warning signs, a faint tremor here, a sudden plume there, are present for those who observe closely. The Pacific Plate's true story is not one of placid endurance, but of endless transformation, of calderas born and reborn, and of landscapes rewritten. The closing question remains: Will Earth's largest plate one day reveal an upheaval even greater than any in history? Or do deeper secrets remain hidden, stirring far below? What do you think? Could we witness the awakening of the world's largest caldera in our lifetime? Or are Earth's greatest volcanic episodes truly behind us? The search for answers among deep-sea ridges and ancient ash, in quiet laboratories and on restless shores, continues. For those drawn to Earth's hidden stories, keep seeking, keep questioning, and remember, the most astonishing chapters may yet be waiting beneath that eternal blue expanse.